Hello and welcome back. Welcome back, everyone. We are kicking off the day 3 of AWS User Group Pune Security Week, and the energy is electric. You can see many of the people have already joined, and they are waiting for today's exciting session. So today we are thrilled to have Shagun Beniwal, a true cloud security champion and AWS technical account manager, join us live. Shagun brings a wealth of experience to the table, and we are excited to have him delve into the world of Amazon GuardDuty with us. So let's start with our quick introduction presentation for today's uh, the security week that we are holding here. So I was getting a few questions as well. I covered them yesterday. Why we are hosting this particular security week? So let me share my screen and let's go through the presentation once. Yeah, so we are for this particular security week, as I covered yesterday as well. We had done a AWS Community Day DevSecOps edition in January 2024, and we got a massive response to that particular event. But we could hear from many of the people that they could not make it due to the distance or due to the limited availability. So for them, we are going to make sure that they will learn from the community and they'll get opportunity to listen from the expert speakers that we have. So that's why we have organized this particular security week from the AWS user group Pune. So why this security week? So this security week will be helpful for the users to enhance their AWS and cloud knowledge. So we have speakers lined up who will uh, share their knowledge and insights about various AWS security services and how people can improve their security posture as well. And if you have seen last 2 days, and if you have not seen, you can go to the recordings on YouTube and LinkedIn and see how the services like AWS Inspector or Security Hub have helped us to improve the security posture and the detailed demo about these sessions as well. Okay. And apart from that, this particular session will help us to stay ahead of the latest threats and improve our security posture. Then we'll get the insights from speakers. For today, we have Shagun with us, so we'll get many insights about the Amazon Guide Duty, and we are going to see and we are going to listen from his own words as well. And apart from that, you'll get a chance to network with the speakers and attendees that we have on LinkedIn and YouTube. So please go ahead and make sure that you grab that opportunity. And you even in these sessions, you can ask your questions in the chat, and we'll be glad to help you with that as well. Okay. So without delaying, I'll just explain the sessions that we are going to cover in this particular security week. We had our first session on day 1, that was AWS Security Hub by Kirti. On day 2, yesterday, Samiksha Garg covered the Amazon Inspector and the insights about it. Today is day 3, where Shagun will cover Amazon Guard Duty. In day 4, we have Amazon Messi and Amazon Detective that will be conducted by Anjali Sharma. And for day 5, I'll be talking about AWS Web Application Firewall and Shield, and how we can improve the security posture with various AWS services as well. Okay. So for today's session, we have Shagun. He's AWS technical account manager, and he's going to speak about Amazon Guard Duty and how we can protect your AWS accounts with intelligent threat detection. This will be kind of advanced topic for today because he's going to deep delve us into many of the aspects of Guard Duty and how you can secure your AWS accounts and data as well as workloads hosted on AWS. So let's give the stage to Shagun. And Shagun, I would request you to introduce yourself in your own words, and then we can start with the actual session.
Sure, Vishal, and thank you so much. I think you've done a lot of introduction already on, probably what I was about to say. But yeah, good morning everyone, and thank you all for joining this session today. And so today we'll be looking at advanced threat detection with Amazon GuardDuty. This is a threat detection service that comes as an offering from AWS. It's a managed threat detection service that we have, and that's what the topic is for today. Just kind of again one liner about me. I'm Shagun, and I'm a technical account manager here at AWS. I support large enterprise customers, which are geographically spread across various continents and countries, you can say. And I'm also a part of the security community here at AWS. So you can say, you know, the the entire day that I kind of spend here, that's where I kind of look at security in various aspects, as well as handling customer like movements and migrations and various other things around security, as well as in general technical acumen areas. And so before we start today, I think let's begin this entire conversation with a narrative. When we talk about security specifically, detection and investigation of threats is very crucial in building a cybersecurity strategy specifically, right? So if you want to build a good cybersecurity strategy or a response program for your organization, you need to have detection and investigation of threats being put in as a very crucial and a fundamental block into it. So that's where I would say organizations today, the amount of time that they are utilizing to identify these threats, and I would say assessing these threats, investigating these threats, identifying how this entire attack evolved in an environment. That's where the entire space is where we want to speeden up that entire reaction. So any cyber attack that is there, on how well you respond to it is how fast you can recover from it. So if you are able to detect faster and if you're able to investigate faster, then you're able to recover faster. So this is the narrative that we have. So that's how things kind of spit in the bigger picture. Because as Vishal mentioned, you've already looked at other sessions where you had security hub for the posture management of the cloud. Then you also had inspector for vulnerability scanning and management of your workloads. So those are pieces of the puzzle, but in totality the process is where you have to speed up this entire reactions of moving quickly into any specific area. Like it can be vulnerability management, it can be threat detection, it can be incident response, it can be, you can say, data protection. So any specific area that you have, if you are able to move faster in that area, you will be able to defend against attacks, and if not defend, you will be able to recover faster. So that's the idea that we want to bring out. And without further ado, let's dive into understanding, what this topic entails today. So, as an agenda, we'll be looking at things like what is the current threat landscape today that we have. Then, how AI/ML is playing a role in cloud security. You must have all heard about, generative AI, specific AI/ML courses, and then, specific threat detection tools that are using ML, which is machine learning on the back end. And so that's where I just wanted to touch a little on what AI/ML is, and how that would help, and why we're talking about tools using this technology today. And then we'll talk about Amazon Guard Duty on how that helps in preventing these large scale attacks when they start evolving in the network, and how we're able to detect and start responding back to them. We'll do a demo where I'll walk you through the console to show you how the entire thing of vulnerabilities, and not vulnerabilities, but the entire way of how the findings come out. So these findings are classified into different categories, and these different categories are what I'll show you today. Later towards the end, we'll open the floor for Q&A, and however, feel free to keep posting your questions in the chat, and wherever possible, we'll start answering those questions as well. So, talking about the current threat landscape today, you know, there are two specific things I would, bucket this into. So, the first thing is the common threats that we generally see, right? So, when we talk about security at any point of time, you will generally see people talking about, denial of service attacks, which is your DOS attacks. And if those are coming from, various different points, it becomes a distributed denial of service, which is your DDoS attacks. Then you have application vulnerabilities, and then you have bad bots. So app vulnerabilities is where you have things like SQL injection, cross-site scripting, OS top 10. So these are specific things where you can say that attackers would try to exploit gaps or vulnerabilities in your applications, which essentially would give them a way to move into your network. So that's essentially how the application vulnerabilities piece is kind of pictured here. Then we have bad bots. Bad bots, again, bots are like scripts, you can say. These scripts are specifically, written to achieve specific tasks. And why we're calling them bad bots? Because they are achieving tasks which are not good for our environment, or our application. So they'll try to you know crawl the entire website. They'll dump all of that data, and they'll create an exact looking website that we have, right? So ultimately what happens is they are now creating a phishing website out of it. So any bot which is trying to do some malicious activity on our website and something which is not permitted is categorized as a bad bot. Another example I'll give you, you all must have seen those flash sales that happen, right? Where you are told that you will get a certain product for a certain price at a certain point of time. You just have to log in, create an account, put that product into your cart, and ultimately the moment that timer hits the sale time, and you keep clicking, but you don't really get that product ever, right? So how does that happen? What is it that's happening behind the scenes? So there are scripts that people write which can help you to bypass all of these things, and in an artificial way keep clicking on the buy button and add products to the cart. So ultimately all of that entire flow is automated, and the moment the timer hits, because machines are faster than humans, right? So they will click on that icon of buy. The product will automatically be moved to the cart. The cart will actually be built, and then the product will be kind of taken away somebody else. And on the contrary, what humans would do is they will just sit on the cart, and they'll try to keep buying the option, they'll keep clicking on the option for buy, but essentially the stock is out. So that's another example of how bots can actually play a very, I would say, malicious role. And they create an artificial scarcity of things, and that's how the prices get inflated. So there's a lot of things that goes behind the bots part as well. And denial of service I didn't specifically cover in the starting, because there are multiple types of attacks that can happen here. It's not a very I would say straightforward kind of thing. You have to have a lot of infrastructure. You need to have like a strong network bandwidth so that you are able to overwhelm the malicious target, or the target that you are deciding on. So there are things like SYN floods. There are things like you can say reflection attacks, then web request floods. So there are multiple things that you can do. But yeah, I think if you must have heard that reflection attacks were quite prominent some time back, and they were like in magnitude of terabytes per second. So the I think one of the popularly known stories is that AWS was able to defend against a 1 terabyte plus per second attack that was coming towards its network. So that's how those stories are there, and that's the kind of magnitude that we're talking about. So essentially, these are common threats, but as we're evolving, right? Digital footprint is evolving, digital technologies are evolving. So there are modern day threats also that have now come up. So when we look at modern day threats today, so threats like 0 day vulnerabilities, 0 day attacks, you can say, and like advanced persistent threats, which are your APTs, and then polymorphic malware. So these are specific categories that we are trying to highlight, where a lot of investment and work is done by attackers today. And specifically giving an example for some of these things, the first one is the 0 day attack. So a 0 day attack specifically, as a definition, it's just that it's some vulnerability which is not publicly known, and the attackers are trying to use it for their access to a network, and the developers of the application also probably don't know about it, right? And they keep using it, and they keep moving into systems, they keep hacking systems, they keep moving into the network, and they maintain their persistence. Once they maintain their persistence, they can do various things. They can start dumping the data out, and they can start looking for credentials. They can understand the internal processes. They can steal the internal tools, the internal reports, any financial, I would say, statements. So various things can be done depending on what they really wish to do and what they really find in the network. So one popular example for a 0 day attack was the log4j, which was recently highlighted a lot, and probably the world was you know using log4j libraries to, in their Java application. So, and that's where you can say that, everybody was moving to patch their applications as fast as possible, because there was a known vulnerability out there, and, it was exploited at, a very high pace. Then advanced persistent threats, as I mentioned, that, once these attackers move in to your network, they will very silently sit down, try to understand what's happening. They will try to understand your security systems and evade, any security, I would say, systems that are trying to detect them. So the attackers are trying to become more intelligent. A recent example again, SolarWinds attack. It was a supply chain attack that happened, and attackers injected malicious code in one of the updates that was going out for the Orion software. Orion software is basically the software which was bugged, and about 30,000 companies, big and small, were affected. It's an estimate that they were affected. It could be like even more companies were affected. So, and there were about 70% or 80% of Fortune 500 companies were also a target of this at some point. So that's where we are talking about massive scale, huge scale of these attacks coming in. And then lastly, polymorphic malware, because we know that today the security tools are becoming smarter. So attackers know that if they also become smarter, then it's a one-to-one fight, right? If attackers are not smart, they will be the security tools who will win, right? So attackers try to understand what security tools are trying to do with them. So they will try to change their signature. Like every time a malware or a virus, you can say, tries to run, it will try to change its signature. It will try to check which environment it's running in. If it is running in a VM, then it will probably shut down itself. Right. So there are many things that these polymorphic malware try to look at, and that's how they try to evade the systems that we traditionally have. Just to again set more context, I would say we are talking about the modern day threats, so let's look at the cost implications of a few things. So here is some data breaches that we have collected. The source of this data is IBM, and it has data coming from 2021 and 2022. So it just talks about that what is the average cost of a data breach. So any data breach that you see today, the average cost of recovering and like cleaning up and probably negotiating with you know malicious actors, it roughly costs about $4.35 million. Contrary to that, if it's a ransomware event, the cost goes up a bit. It is $4.5 million, and the average cost of any critical infrastructure data breach, any data breach that you do, and if it is on a critical infrastructure, then that results in about $4.82 million. So that's an average story of the industry. Healthcare is the most hit. Probable reasons that because of COVID, many healthcare systems started expanding because there was a lot of demand and all. So that's how healthcare was the most targeted one as well. And then financial is always the famous one, right? And that's always a favorite one for attackers. So just taking another minute to kind of talk about the attack chronology. So if you see, there is always a reconnaissance phase that happens. Reconnaissance means somebody's trying to knock your door. They'll keep knocking the door, and they'll keep trying to find out where the softest part is, so that they can break that part. And the knocking happens, and then there is a point where breach happens. The breach is where you see that the attackers are in the network. But again, we don't realize that because we are still not aware of the attackers being there. And then there comes a point after that breach. It can be so the mean time to identify is about 200 days. So for 200 days, an attacker stays in your environment and you don't even know it. So that's like the figures that we have, right? So that's approximately 200 days. That's what the mean time to identify is before the breach is detected. And once the breach is detected, it takes about another 70 days to get recovered. So ultimately, if you sum up everything together, it's close to an year that you take from the point you are breached to actually you are recovering. And that's the scale of how cybersecurity is becoming more and more essential, and why cybersecurity in general is becoming essential, and then how security is playing an important role in today's digital footprint. So simple way how to kind of overcome this is that start detecting early. The moment you start detecting early, you will keep reducing the mean time to detect. If you have detected early, you will be able to recover early. So that's how you are able to kind of reduce this entire thing, and that's where we have to reach. So just touching on the AI/ML part that I talked about. So many people would be talking about fancy stuff like AI. What is ML? What is deep learning? In a nutshell, this is what AI/ML is. AI is the biggest set, you can say, or the superset. And inside of it, there's a smaller part which is called as machine learning. And inside of machine learning, there's an even smaller part which is your deep learning. So, then artificial intelligence helps you to, I would say, in simple words, it helps you to mimic human brain. How humans react to things is what AI is trying to, give you through software and your machines. So humans are able to understand each other's language, right? So machines are now trying to understand when humans speak as to what needs to be done, right? That's, for example, you can say Alexa, right? If you given a command to Alexa saying that play music, so Alexa is a computer machine, right? It tries to understand when humans speak in their own language, right? You can speak Hindi, you can speak English, you can speak Spanish. It tries to understand that. So that's where you are using those AI models to do a natural language processing. Then you have text to speech. When when you're writing actually things, it actually converts them into speech. So so on and so forth. Machine learning, again, this is where I would say a lot of the development is happening, where we are pitching in machine learning technologies to give that edge to our security services, where they're able to detect advanced patterns. So they're able to correlate. So if I give you like 5 patterns and say that whether this pattern that I'm trying to now see is similar to them or not, that's where machine learning tells me that yes, this is similar, with a confidence of 80%. So 80% I can say that the thing that you're now showing me is similar to the attack patterns that I have seen. So that's how machine learning plays into. And deep learning is, again, how human brain mimics how the neurons in the head is kind of used to make different actions, and like different processing of different thoughts. So that's how deep learning comes into the picture. But in totality, this is what this entire area is. Introducing the AWS security services specifically, there's a whole lot of services that we have. You have we have segmented in them into multiple categories. But for detective control specifically, we have GuardDuty that we are focusing on today. Threat detection using GuardDuty, that's what we are here for. Initially, like what problems we are trying to solve, what problems we actually saw in the industry were that there are too many alerts that today, if you are a security expert, you will see hundreds and hundreds and thousands of alerts coming into your environment, because there are so many machines, right? How do experts or security engineers like us are able to fine tune and identify that these are the 10 or 15 or 100 uh, alerts that we need to really worry about, or really need to work on? So that's how we are able to try and give that specification. We are trying to give that classification through like the tools that you're building. Complexity of tools and vendors, there were multiple tools earlier, right? Multiple tools with multiple integrations, multiple processes. One format was not supported by other tool, so multiple formats have to be done. You had to run your ETL jobs, so multiple things have to be done. And then there was a lot of complexity and pricing issues, right? So now we are trying to solve all of that through a single click deployment, and everything just gets connected to each other in a seamless way, without you even getting to know. Then lack of visibility into security risks. Security risks are you know always there, right? So you just have to identify, and you have to start prioritizing them. So you need to know that which particular EC2 instance is trying to connect to a Bitcoin mining pool or a Bitcoin mining server. So those risks are there, but how do you identify them? So we also try to give you those visibility into the risks. So these are just examples, right? So there are many things that GuardDuty helps you to do with. And so just introducing the service formally now. So Amazon GuardDuty is a threat detection service which uses machine learning, as we just talked about. It uses your anomaly detection, and it also uses your threat intelligence, which is built into it. And then it tries to prioritize everything, give you findings which are highly classifiable with the context of your environment. So something as direct as saying that this EC2 is trying to contact a malicious domain, so you directly get the name of the EC2. EC2, basically, people who don't know, EC2 is basically the server or the compute server that we have on AWS. So that's where you kind of host it's basically the VM where you host your applications. So it actually tells you to the point, which IP, which subnet, which VPC, which instance is trying to access, which IP, and why that IP was highlighted as a malicious IP. So all of those things are there. Features, again, single one step click, you set the activation, you start the entire process. Then continuous monitoring of your accounts, global coverage, then detect known and unknown threats, because we are saying that it is contextualizing and understanding information from your logs that you are generating in your environment. So the context kind of comes from there, and once you have the context, you can start personalizing those threats and those informations from your own environment. So that's where this becomes an important part, integral part. And then uh, more on the diagrammatic flow of how this works. So we have data sources, right? For any security analytics, tool to work today, you need to have data sources feeding that. Once you feed that data to the particular security tool, the security tool has its own way of identifying these as attacks, or like not as an attack, and then it finally gives you findings. So we're using VPC flow logs, DNS flow logs. We are looking at CloudTrail events, login events from RDS Aurora databases. Then we have S3 data plane for S3 protection. Then we have your you can say EKS control audit plane. So we are looking at a whole lot of logs that are going into your security analytics tool on the backend, which is your GuardDuty. And GuardDuty, again, as mentioned, uses continuous learning to understand how your patterns are evolving in your environment. What is normal, what is not. That's what GuardDuty tries to learn. And machine learning models help in testing and identifying whether a particular attempt to a database was anomalous, or was it right. So again, just small example, think about that you have a database where you are trying to log in through your applications and you're trying to fetch data, right? Suddenly you see that a user is all like a user is logging into your database. Like, a user means somebody from the console is coming and trying to log in, or somebody from outside AWS is trying to come and log into your database. The application has never seen a login from a user using these credentials from third party tools or from some AWS service. That becomes anomalous, because the entire system has been baseline saying that there were no calls that came out of AWS, but now somebody is trying to connect from outside of AWS. So that's where this becomes anomalous, and this is the learning that we have from your own environment. So that's what we try to understand, and that's how we try to highlight these findings to you. And so these are the protection plans, where you have your SC protection, EKS protection, malware, RDS protection, then Lambda protection. So there's another thing which is runtime monitoring that has now come, and because this is an ever evolving service, I would say, and we are heavily invested in kind of creating more and more features and coverage to the entire service. So that's how runtime monitoring is not mentioned here, but that's another feature that is there. I'll show you that to you on the console once I open that. So S3 is basically where you store all your data, which is your objects, and protection of S3 is important because all of your customer data, your critical data, your health records, your PCI records. PCI means payment card industry. So any financial transactions that you're storing for any reason, kind of also needs to be protected. So that's the area, that's the hot area where attackers try to hit hardest. They know that critical data is there, so that they can extract it and they can keep the company hostage. So that's how they try to do that. So S3 protection is very important. EKS protection, on the other hand, because most of the companies today are trying to move on to containerized workloads, and they are trying to have orchestration tools where they specifically are not investing in managing the infrastructure. They are just managing on deploying these applications and containerizing them. So that's how EKS protection also comes into picture, where threat detection of you know any threats that are looming in your containers are detected through EKS. So, we have the EKS control plane logs and your data logs, the EKS audit logs, that we combine together to identify how and what kind of privileges are tried to, use in the entire container system. And, like whether root credentials were tried to use or not. So, the best practices are there. We try to assess on how and what kind of things are being done on the EKS side, and if we find them anomalous, we flag them, right? So that's again something that we do. Malware protection, any EC2 that you have today, or any container workload that you have today, they might have malware, right? So a malware can get downloaded from somewhere. Somebody has installed something on your system without you knowing. So, how do you really scan it? That's where the malware protection comes into picture. This piece will help you to automatically scan. And if a malware is identified, the scan snapshot will remain in your account. You can choose to keep it or not. That's a setting, but you can keep it for further assessment on to understanding what really happened and how this malware came about. So that's again malware protection. RDS protection. We are only looking at supporting the login events for Aurora today, and that's where I would say this is Aurora and Postgres compatible instances only. So we are expanding this again so that we can have a wider coverage on the database side as well. But RDS protection specifically looks at any anomalous behavior that you can see in terms of login. Somebody's trying to brute force the password. Somebody tried, like submitting password for 100 times, 200 times, 500 times, and that's brute force attempt, right? So that's something that gets detected. Something like an anomalous login that somebody tried logging in 300 times, and on the 301st time he was able to or she was able to log in. That means that this login is anomalous, that while it is brute force, but the login happens, that becomes an anomalous login. So things like that. Then lambda protection, because most of the customers today are also moving to serverless. Protecting the serverless also becomes important. So lambda is a serverless compute service that we offer, and this is where you just have to write the code, and the backend infrastructure and memory and everything gets provisioned on its own, and you just basically kind of get the output of what you really want. So that's how the lambda protection is becomes important, and we are trying to scan your VPC flow logs to check for any network intrusion, any network activities which is malicious on the lambda side. So these are the protection plans that we have. Multi-account strategy. This is where I would say on the left side, if you see on the left side of the screen, you see a workload account. So a workload account basically means that any general account that you have where you're trying to create your applications. So this is where you have GuardDuty, Macy, Inspector, Config. So all of the security services deployed. Then you on the right side, if you see, there is another called account which is known as a security account. The security account here is where you have you know like you have consolidated all the findings from each of the accounts. So there can be multiple workload accounts. It can be that you have 15 workload accounts, but the security account is one single account where you will start seeing all of this consolidation and these findings coming in there. Once all of these findings come to security hub, you can have an organization wide view in understanding what really is happening in your environments. So this is a powerful, I would say, way to understand and consolidate everything in a single point. And then obviously, as we say, principle of least privilege, people who are only required to have access should have access to things. So the security team can directly have access to the security account, look at everything, manage all of your services, enabling them, disabling them, probably pulling the logs out, and doing things like that. And nobody else will have access to security account except the security services team. So again, privilege escalation, all of those things, we try to maintain principle of least privilege so that we can avoid privilege escalation, unnecessary uh, people touching data which they should not be touching. So we're trying to create that boundary through this segregation of the accounts. So this is a multi-account strategy and how the findings really move from one account to the other. So let me so there are protection plans that we have which are explained in more depth, but let me do one thing. I will quickly show you the GuardDuty malware protection. So and then I'll take you to the demo part. So this is important because this will help you to understand how really the scanning of these EC2s is really happening on the backend. And this will also help you to understand that how the thought process goes when you're trying to build these services, and when you're interacting with these services. So the on the top of the screen that you see, that's a customer account, right? So it is my account, right? For example, I'm a customer of AWS, so this is my account, and the GuardDuty service account is also present there as well. So this GuardDuty service account is where the service GuardDuty is kind of running their snapshots and everything. So this is where all the management of these findings and how the snapshot scanning and everything happens. So if I have an EBS, because we are talking about, EC2s scanning. So EC2s essentially are just compute, right? So when you put them along with EBS, that's where the storage part comes. And the storage is where the malware can, kind of be deployed. So you scan the EBS, and for scanning the EBS, and to identify findings from it, you create a snapshot of it. Once you create a snapshot of that EBS that you have would essentially be that snapshot that you create would essentially be then sent to the service account. That service account now keeps that EBS snapshot with it and scans it. There are internal backend scanners that we have that will scan the entire thing. And if there are vulnerabilities found, it will report that as a finding to GuardDuty. If vulnerabilities are not found, it will discard the snapshot and it will say that there were no vulnerabilities found out. So that's the simple process and simple workflow that we follow. Now, just as motivation, you know, these are like building blocks of any scanning, approach. You will definitely, if you try to sit down and think about how. So I'm not trying to say that this is, like one way only. There can be many ways, different, definitely. It's just that I want to invoke your thought process of how these flow diagrams help you to bring that thought into your architecture side. So try creating these flow diagrams that gives you more into, I would say, more knowledge into what you really are trying to deploy and create. So this is how this is. And without kind of spending much time on this, let me quickly break this to the demo part. Right, so you should be seeing the console now. So this is the GuardDuty console. How do you come to the GuardDuty console? You simply, like when you open your AWS account, go to, the top search bar, type in GuardDuty, the service name highlights, you just basically click on it and you move into the console. Once you come to the console, you will see that, it gives you total number of findings, right? So total number of findings are given to you. So it says, there are on 28th February today, there are 3 high findings, there are 28 medium findings, and there are no low findings, right? So this gives you a one-stop shop, like kind of the moment you enter, you understand, what's happening today in your environment. Digging deeper, let's say that, you want to see which are the most common types of findings. So most common types of findings, again, unauthorized IAM access, this is one finding, malicious IP caller. So, some IP which is put in a threat list is trying to get contacted multiple times, or we are trying to contact that IP multiple times. So that's where the malicious IP caller dot custom kind of finding comes into picture. The definition of all of these findings are there on the GuardDuty documentation itself. So you don't have to remember everything, like mug up everything. It's just that whenever you see these findings, you can just go check on how we have you can say that how you can probably define these findings. You can just go into the documentation and just go through that. The next step is that resources with most findings. So, like for example, this instance that we see here, this EC2 instance, this says that this is coming from account ID this, like which is my account ID right now, and it says there are 4 findings around it. Now, as a security engineer, like think about it. If you are given this table where you have resources with most findings, as a general thing, what would you do, right? You will just directly go and try to check, what this EC2 is doing and what are these findings about, right? And if you try to see, and if there are high severity findings attached to it, it might be a possible, attack that is really happening in your environment. So that's how you can selectively move to identify resources where you have the maximum number of findings. And if those findings are really, the findings which you should be attributing to any attack. So that's the kind of classification that you can start doing. Then the last generated one, this again column gives you when the last finding was generated, and when was the last finding reported. So this is how it is. Then it's not just that we're talking about resources, so it's not that we just look at EC2s. We will start putting in your EC2s, your EKS nodes, your you can say EKS cluster names, then your keys, access keys, whichever are used for specific API calls that we feel are malicious, depending on your environment and configurations and the machine learning models. So this is again, then least occurring findings. You know, one narrative can be that least occurring findings can be why are we talking about least occurring findings? That something which is very very silent in your environment and something which is quietly executing in your environment might actually be an attacker's move, right? Because attackers don't want to create a lot of noise. They know that if they create a lot of noise in your environment, some or the other log will pick it up and some security tool will take it, and they will be able to correlate and they will give you saying that the account is under attack. So that's how they try to stay as simple and as low as possible in your environment. Once they move in, they will keep lying silent for months before they actually make a move in your environment. And again, here why we're talking about least occurring findings, so we are saying that least occurring findings, so we have selected high severity findings, but those are least occurring. We can say that there is a cnc activity, meaning there is a command and control activity where we are trying to contact a bitcoin mining dns, basically a Bitcoin mining pool, which I will just kind of show you on how we can dig deeper into it. So there is a Bitcoin tool that is probably installed on one of your EC2 instances, which is trying to mine cryptocurrency. So this tries to give you that kind of hint on what really is happening. And if you go to these instances and if you see high CPU usage, then when you try to list all the processes within the EC2 that you have, you will definitely see that there's a high level of CPU because Bitcoin mining is done on like they exhaust the systems, they try to mine as much as possible. So you'll definitely see as another indicator of compromise will be your high CPU. The second thing is when you try to see where this connection is going from the network, this would definitely go to a Bitcoin mining pool, because all of the Bitcoin mining jobs that you get, so those are essentially the ones that you're actually doing a smaller part of the entire puzzle. So when you combine all of these things together, then you result to a bigger I would say Bitcoin. So that's how these pools work. If you're interested, do read about how the Bitcoin mining pools work, and how you kind of get paid back, and how the rewards work in this entire space. So this is the summary page, right? So straight away we get that 29% findings have increased in one day. So now this is like huge. And out of those 29% which have increased, three are high severity findings. 16 findings are resources. So total 16 resources are there which have the findings, and one account. Why this account part is there is because you can have multiple accounts, like just we talked about workload accounts, right? You can have multiple accounts sending their findings to a specific single account, where this dashboard makes even more sense, because then you have classification on account level also, that this account has these many findings and these many resources have the most number of findings. So those kinds of granularity is what you get out of it. And if you come to the left side, this is where the heart of this entire thing lies. This is the findings, that anything that is abrupt, anything which is anomalous, anything which you feel is out of line, and something which is probably not right and malicious is the place. This is the place where we kind of put that up. So findings on the left side, if you click on the findings part, let's filter from the right side with high severity findings. So I just selected high severity findings. So these are the three findings. Let's try to click on any of these. Once you click on them, it opens a deeper detail of this one finding. And it also tells you that what really happens, right? What's really happening. The EC2 instance with ID, this particular ID is querying a domain name which is associated with a known command and control center. Now, if you remember, we talked about Intel threat intelligence, which is inbuilt into GuardDuty. Now, why we're calling it as known? We're calling it as known because we already know, basis on the threat list and the threat intelligence that we have, that this particular command and control center was responsible or was involved in malicious activities in the past. We know all of that from the threat intelligence that we already have, and now what you're doing is you're just using that to identify if there is a certain pattern that we see in your environment also. So this is a clear straightforward case where we can say that something malicious is happening, because unless we know that why this is communicating outside, this is for sure an activity which is malicious. Then what are the other details that you get around it is, this is a high severity finding, which region this finding is coming from, and how many counts. So count means how many times this was seen, how many calls were made outside, how many different instances of this call was seen. This is the account ID. Again, this is all on the right side of the screen. I'm trying to show you. So we also get the information about what is the size of the instance, the ID, whether the instance is running or whether the instance is stopped, and where exactly the instance is located. So there are multiple availability zones. So we also spot that so we also give you that availability zone where this is kind of there. So if you see like security engineers, they can just see that if one specific availability zone is shown again and again, that means that all of the instances in that availability zone needs to be verified and checked quickly. So that means the attack has started from there, or is kind of existing at that point of time in that area. So this is how, again, you can say AMI ID which you are using. Then other important stuff would be this one. Why we highlighted this? This was highlighted as a part of a DNS request which was made outside, and what domain we queried. So it's important that we identify the right domains, because it tells us that whether these domains are malicious or not. So GuardDuty, C2 activity b.com. So this is one of the domains that is present in one of the threat lists, and that threat list is where this was highlighted from. Now if you want to dig deeper, say that you have multiple threat lists, like where this is coming from, what threat intelligence you use. If you want to know all of that, so we also tell you the name of the threat list from where this is coming. So Amazon is the name of the threat list where this threat IP was identified from. So this is how we kind of can dig deeper into each of these findings and understand what is really happening. Another way of identifying and correlating all of these findings together is through the detective, Amazon detective. So that's a session that would happen, I think, tomorrow or day after. I think that's tomorrow. So anything that you do and see in GuardDuty can be extended to be correlated through multiple findings. So, for example, if I just want to say that are these three findings related to each other or not, detective will give you a graph showing that which finding is related to which other finding, and which EC2 instance has the maximum number of touch points for any finding. So all of that is presented in a form of a graph, you can say, and that graph has different nodes. That nodes tell you that how these connections are moving. That helps you to trace back the attack, tells you where the impact is. It also helps you to understand which areas you need to first focus on. So that's how the detective service would help you. Do join tomorrow's session as well, because this is like an extension to what we are doing today, and these services kind of complement each other. Apart from this, another one, if I just scan and show that, yeah. So this is again the upper one was CNC activity for Bitcoin mining, and the lower one is cryptocurrency mining. So this time the domain name has changed. This is an actual domain name, right? Minergate.com. So this is an actual pool which is used for mining Bitcoins, and that's how we kind of also give you the domain here. And on the usage part, on the left side, if we scan more, you get a usage in terms of how much you're going to be billed for, like the average expected cost that you will see in a month, depending on your environment. So this is a good handy feature to understand whether you are on track in terms of your financial goals or not. Then the next is malware scans. As I mentioned that today EBS storages can have malware, container storages can have malware attached to them. How do you kind of check them? You can initiate these scans. So these are like scan IDs. So we're saying that in malware scan we scanned these two specific EC2s. This is the one and this is the second one, and the scan result was both of them turned out to be clean. And if you want to just go into and check that 1.8 GB of data was scanned to identify whether this was clean or not. So that's probably the amount of data that this is holding. And it also gives you the volume ID of the EC2, basically the volume name and which volume is attached and the total size of it. So out of this 8 GB, 1.8 GB was scanned. So probably this 1.8 GB is where you have the data resting for you. Quickly moving on to protection plans, I explained most of them, and I'll just talk about. So these are like simple enable disable options that you have. So once you do an enable disable, it's automatically starts working. Similar with EKS protection and runtime monitoring. So this is something that has newly come up. So runtime monitoring really helps you in actually putting guard duty agents into your environment, and these not just environment but your own EC2s and compute nodes. So currently it is supporting EKS, ECS, and EC2 is under preview. But once that preview kind of gets over, you will also have the ability to put in the uh, agent guard duty agent into your systems, where the guard duty agent will try to assess on any host based malicious behavior. So it will try to check for any file accesses, any outbound network connections that we feel are malicious, and like any specific areas or any process execution that it feels that is malicious. So we're now giving you a view of what is happening within your hosts also now. So right now we are talking about everything on the network side, the cluster side, all on the environment level. But now we're also diving deep into the environment nodes. So that's what we are now achieving through runtime monitoring. And again, simple enable disable options. It's all plug and play. You don't have to really do any sort of integrations. It's all transparent to the human. And then uh, malware protection, another important feature for malware protection is you can include or exclude your resources based on tags. So for example, if you say that certain resources have a tag saying do not scan, those will be excluded from the scan. So this is one strategy that you can use to only scan your production workloads to reduce cost and speed up the process of scanning. So that's how you can look at exclusion and inclusion of tags. On demand scanning, this is basically you put in, if you are doubtful about a particular EC2, put in the name here and the scan, you can just click on start scan. So this is how easy it is. Again, RDS log monitoring we do for login monitoring, and this is Aurora databases and Postgres compatible databases are supported for now. We are expanding this again to other flavors of RDS. Lastly, Lambda network activity monitoring. This is again something that we discussed. Right, we try to look at the network VPC flow logs to understand any malicious attempts of network movement that are trying to done through the Lambda invocations. And then this is accounts part. You can have, when I talk about the multi account architecture, this is where the story now completes. You can start having those accounts get added to your single account. So the single account can actually serve as a picture of your entire organization. So this is how you start adding accounts. You can enable disable different protections from here itself. All of these protection plans that you see here, you can enable disable them from here itself. You don't really have to go to other accounts. If this is marked as a delegated administrator meaning if this is the admin account for the entire organization for guard duty, then all the processing, all the enabling and disabling of these different protection plans can be handled from here. All the findings can be consolidated here. So that helps you to understand the current state, and this is like a pretty straightforward and easy way to have a full organization check on what you really have enabled and disabled. And then lastly, just another 1 minute here. And then lastly, this is your settings part where we just talk about, like creating sample findings. This is important. If you have guard duty switched on for the first time, because it's 30 days free, right? So you really need to know how you really want to interact, and you want to deep dive into it. You can generate something called a sample finding. These sample findings are going to help you understand the format of each finding. They will also help you understand what kind of things you are able to detect and how these things are shown onto the console part. So these generate sample findings. So these are all sample findings, right, at the end. So once you generate them, this is only one that I think you can generate. So once you generate them, this is like one sample finding for each type. So whatever guard duty findings are supported today, like one of those, like, one each of those will be created for you, so that you can understand on what context and what parameters you are capturing for each of these findings. Then suspending guard duty and disabling guard duty. You can suspend if you don't want to kind of keep running it, and if you can disable if you want to totally remove every finding that you have, and you want to just close out the service. That's how you can do it. Simple question, straightforward. Again, what if we want to put in our own threat lists? We want to put in our own threat intelligence, right? If we have threat intelligence coming from somewhere else, for sure, go ahead, put in your threat intelligence list here. This is the list of trusted IPs. This is the list of threat IPs. You can add a list here. Simply go ahead and just put that file into an S3 in a text file and just reference it here. So the guard duty now has more knowledge about your context and your own environment. So that's how we complete the story, and that's probably what I want to cover in the demo part. Yeah, and so if there are any questions, we can take it up now. And yeah, over to you, Vishal.
Thank you, Shagun. Yeah, we have many questions from LinkedIn and YouTube, and people are feeling this very useful and they are trying to know few of the things. So I'll start with one very good question. That is from Bernard. Can I customize GuardDuty to focus on specific threads or resources? If yes, how can we do it on console?
Okay, so when you talk about customization of guard duty for specific threats and alerts, so there are APIs, right? AWS is entirely built on APIs. So the moment you have these findings coming in, you can use those APIs to filter out on what you really want, and like put that into Event Bridge, and Event Bridge can start giving you alert only for those specific, I would say, these findings. So you can create those custom scripts. You can do Python code to pull all of that findings, filter it out, send notifications out through SNS. So that's how you can do it. But on console, customization specifically is only through filters. Like if you want to put some filters out, that's the only way. But yeah, specifically only looking at uh, specific resources is, again, you have to just put the filters out.
Right. Yeah, we can use thread filters and finding filters that we saw in the demo. We can use
Yeah,
that
yeah,
to
that's
get to
that's on
the
the console.
customers.
Yes.
Right. Okay. Next, we have from Sankalp, um, how threat intelligence is integrated in guard duty.
Threat intelligence is integrated in two ways. The first way is that it has its own backend threat intelligence. So threat intelligence is coming from Proofpoint and CrowdStrike and AWS threat intelligence. So there are three different sources that we are trying to feed into. The first one, CrowdStrike, as I mentioned, that's a third party, partner that we have from which we take the threat intelligence. Then Proofpoint, again, we take the threat intelligence, and AWS itself, because we also see these attacks every day coming to our network. So AWS itself has its own threat intelligence. We build out on all of these threat intelligence things combined together, and we put that into GuardDuty for any detection that needs to be done. Another way of threat intelligence is if you have subscribed to any threat intelligence feeds, or if you know of any specific lists which can give you threat intelligence, that can again be put as a lists option that I just showed. And how you can customize your own lists for threat intelligence.
Right. Okay. We have one more from Preeti on YouTube. Hello, I wanted to know about false positives, how GuardDuty handles it, and how they can be minimized. That's a good question, Preeti. We
Okay,
generally we have the concern of
right,
false positives for any of the services.
right. So basically, one is that when false positives arise, false positives are specifically more when you talk about the intrusion prevention systems. Intrusion detection systems are on the detection side. They detect on what has already happened, right, or what is really happening. So that's where the detection part comes in. So you will see anyway lesser false positives on the detection side. How GuardDuty handles it? It has its own backend models, which it checks. Like for example, I talked about machine learning, right? So if GuardDuty has a machine learning model on the backend, which is checking for all of these incoming connections whether they are malicious or not, or any incoming findings that are malicious or not, it will have a confidence level. you know Obviously that confidence level is all confidential, and we cannot reveal all of those things. That's backend infrastructure. But from that point, try to understand. I can say that, just a simple example. I have an apple in my hand, and I show the machine another apple, and I say, what is the confidence that you can say both of these are apples? So you can say that this is 100% match, right? If I show an orange and then I show an apple, it can say that 60% it looks like an apple, because it seems like round, it seems like same size. So we can say that 50-60% this might be an apple again, but the confidence is low. So anything that is of low confidence, that anyway gets negated. We anyway remove it from that entire list that we showed to you. Another thing, just to build on this, when you have, so the concept of these severities, right? High severity, medium severity, and low severity. High severity means there is for sure good confidence that we can say that there is an attack in progress in your environment. So that's all given in the documentation. The documentation clearly states that if there is a high severity, that means that you definitely need to go and check this, because we, with high confidence, we are saying that there is an attack that is ongoing in your environment. With medium and low, we say that there are chances that an attack is looking to be developed. Like, for example, somebody is trying to knock on the door. They're trying to understand which ports are open. They're trying to understand what versions of applications they are running, so that they can try and bypass those versions. So those are low and medium severity anyway categorized. But for high severity, we are kind of very sure that this is happening, and this has been tested, right? And machine learning models don't just stop at one point, so they keep learning. So even if we give out false positives today to you, the machine learning model will understand that, oh no, this is a false positive, we should probably not show it next time, and we need to learn better. So that's again one thing. And another thing that I want to touch upon is, there can be malicious attempts, but think about it in this way, that you are running a VAPT on your own environment. In that case, GuardDuty will flag it because you are doing a port scan, but you know that you are doing it. So in that case, there is an option called a suppress finding. So you want to suppress those findings because you know that you are intentionally generating them. So those will be hidden from the main findings page that you have, and they will be cataloged into a different area.
Yeah, in continuation with your answer, I guess we can mark is that expected behavior for this kind of false positives if they are kind of uh, the expected things that that we can see on the guard data as well. And then, so that will be considered as a normal behavior, and then that won't be marked as a false positive in guard data as well. Okay. Let me check on LinkedIn if any other questions.
Mhm. Okay.
No, I think yeah, we are good. We have almost covered almost end of the questions we had for today. Mm,
Okay.
So let me open my screen. Yeah. So thanks, guys, for joining today for this day 3 of AWS user group Pune Security Week. We had Shagun with us today, and that was really eye-opening session, Shagun, I must say. We learned so much about the power of Amazon Guard Duty and how we can revolutionize it for the cloud security as well. So, huge thanks to you, Shagun, for sharing your expertise and offering such valuable insights. We truly appreciate it, and your time as well as your knowledge. Uh, yeah, for viewers, remember the learning doesn't stop here. We are still having few more sessions lined up rest of the week, and as Shagun told, tomorrow's session is going to be very informative and helpful to understand the integration with the AWS ecosystem. So stay tuned and follow us for the updates. Thank you for joining us today, and we look forward to seeing you all for tomorrow for another great insightful session. Thank you, and have a nice day.
Thanks, everyone. Take care. Bye bye.
Thank you. Bye.